Now, there's irrigation and then there's irrigation. So obviously, it's the barrier to entry to start an irrigation business or to add irrigation as an arm of your existing business is not that high. You know, you could pretty much get some of the tools that I've listed there, cutters, multi-grips, and you know, anything to dig a hole, some wire strippers and some tools to crush, so multi-grips to crush your wire joiners, and you've pretty much got a basic irrigation business. Now, the risk with that is that most people could just go down to a hardware shop or an irrigation shop and buy that equipment, throw irrigation on their website or put it on their business card, but then they're in a really dangerous position where if you do the wrong thing in irrigation, you can cause a lot of damage. So hopefully today, the amount of information that I give you will get you further down that line. Saved you a spot here. Do you want a drink?
Yes.
Beer or soft drink?
Soft drink.
Soft drink. You sure?
Yeah.
All right. Soft drink. Yeah. So if you can understand, look, I believe it's a responsibility of the industry to help train the industry, and that's why we do it. I enjoy doing it, but I also think that the better you are at installing irrigation, the less trouble our team are going to have from a warranty standpoint and questions over the phone. So I feel like it's just an obligation for us, and you know, the better the installation industry is, the better the supply industry is going to be, and obviously our business is going to do better from it. There's obviously stages after what I've just described where you'll step up from basic hand tools and then start looking at electrofusion welding, gluing PVC. I noticed we've got some guys here that's obviously from golf courses, and I can't see where everyone else is from, but commercial irrigation, where you start to dabble in, you know, 50 mil to 90 mil to 160 mil pipe, and you're doing electrofusion welds, and you're doing, you know, Dakota systems. None of that's covered today, and that's the kind of thing that we'd go into at a higher level. Today is really about understanding precipitation, understanding irrigation as a theory, and then getting enough knowledge to be able to put together a basic drip system, a basic sprinkler setup, wire up some solenoid valves, how the wiring works, how the control, I mean, we won't even really go into controller programming unless someone wants to, and then how it all kind of works. And then if you wanted to expand on that, is that still on? Yep. If you wanted to expand on that, then you can come to an advanced training session. If your business is of a size where you've got 6 or 8 team members that we can do a bespoke training session for, then we're happy to do that as well, and we can come out to your venue. We've got a residential landscaper who we're going to do really just like Wi-Fi controller and solenoid valves as a one, and we'll just do that specifically for them. Or, you know, this whole event started from one person asking about doing some training, and when we were going to do it next, we set a date, and then we invite a bunch of people. So if there's something specific that you would like to add to your string, your bow, your strings, yeah, you know what I mean, then let us know, and we might be able to put together a custom training session for you. Sorry if that keeps cutting out. Finally, we'll have, is that batteries? Yeah, the light's gone. Oh no, it's still there. I'll try and talk loud enough that this doesn't become a problem. So obviously at the end we're going to have some pizza and some beers and that kind of thing. One of the biggest benefits of this for you could be the people that you meet while you're here. And so obviously you're welcome to stick around at 4 if you've been told to be here and you don't want to be here and you want to go home. But it could be a good opportunity to meet someone that you haven't met before that might do something that's you know, a benefit to your business, and you might be able to kind of refer work to each other, or you might be able to supply people. Obviously there's lots of different businesses here. Do you want to just see if you can get that worked out? Do you want to turn the air conditioner off just for while they sort that out? So, licensing. Licensing at the moment in the landscape industry and the irrigation space is quite early in the place of adoption. I've spoke to one of you before who said that they were a plumber. Obviously, if you look at the trades that are probably more recognised from a general public standpoint, you know, the traditional trades of plumber, electrician, carpenter, that kind of thing, their licensing system set up quite well, and the path to getting a license is very easy, it's clear, and then they have to go do it. For irrigation and landscaping, it's not as simple. Another hat that I wear is being involved in the Master Landscapers of South Australia, and that is one of the things we're working on, is to try and make the licensing pathway clearer, not necessarily easier, because we still think it needs to be robust and It needs to mean something if you become a licensed professional, but the irrigation industry is not much different. So there's a bit of ambiguity around licensing. I encourage you to take your own personal responsibility around licensing. If you're actually going to be doing this as a trade, be very aware that if you're performing unlicensed work and you can't provide a license when asked, you do not legally have any grounds to stand on to get paid for the work you've done. The person does have a responsibility to pay for the parts, but not for the labour. So have a look at that. There's a link in my document there for Trades SA. There's a gentleman by the name of Sam who I did a podcast with a while ago. He used to work for the Office of Consumer and Business Affairs. Now he's on his own as an independent contractor, helping people get through the licensing process. So if that's on your mind, I don't have any financial connection to him. He's just a good dude, and I think if I was going to do it, I would use him. So by all means, reach out to him. I don't know that there's anyone else doing that specifically in South Australia. Now, irrigation design and specification. With anything, building a house, building a car, there's no point just starting without a plan. And obviously the better you get at irrigation, the less likely it is going to be that you require a proper plan done by us or an independent irrigation design firm. With design, you've kind of got shops that do design, and then you've got independent design firms that do design. The shops that do design like ours will do free designs up into a certain level. So if you're looking for residential design, either as a homeowner or as a landscape company looking to do the work for an individual, our team can do that for you. I don't know, I think we're struggling at the moment from a capacity standpoint, but generally we try to have them back within 5 days. The quality of the design is going to be directly connected to the quality of the information that you give us. So if you come in with a piece of plasterboard with a non-scaled diagram and when we ask you about the flow, you say it's pretty good, then our design's going to be pretty good. If you come to us with a scaled diagram and you've done a proper flow test, we're able to give you a high quality design that's backed by data. Mudge had handed you out a few of these cards. There's a lot more than that. This is an example. Yeah, so with designs and specification, at a landscape architect level, if we get a system designed professionally, when it goes out to market to be quoted, you guys are quoting apples for apples against all the other landscape contractors or whoever else is actually quoting for the work. We prefer that. It means that the system doesn't have shortcuts that have been driven by individual companies that have a desire to increase their profit by reducing the quality of the system. And that doesn't happen all the time, but it does happen. And if you're losing work to a substandard system, then it's hard because you don't want to change your values around the quality that you want to put in, but you also need to put food on the table. So we are advocates for getting a proper system done. If you're working for a council or if you're doing work for the Department of Transport or you're working for a developer that's building a subdivision for in a local council like Riverlea at Playford, they have to stick to Playford. Well, it's not at Playford, it's at Riverlea, but it's in the Playford Council area. They have to stick to Playford Council. If you're looking at working for Bluestone, like in the subdivision of Bluestone in Mount Barker, then you have to install in line with Mount Barker Council's irrigation specification. It may not come up for you, but it's something to be aware of. And if you're not sure, reach out to an irrigation shop like ours and ask the question. I think the biggest thing to take away from this, if you don't remember anything else that we do, is that we are here, and that if you need help, we get asked similar questions to what you're probably thinking every day at every shop, and we don't mind. Like I said at the start, the better the quality of your installations are, the better the industry is, and then the likelihood is that we're going to sell more irrigation, and then their job security is great, and then we can expand. So don't be shy if you're struggling with how to do something or where to get something or how to fix something. Don't be shy to contact either the Waterpro guys or obviously the team at Railways. And if we can't answer over the phone straight away, they will get back to you with an answer, and then obviously that helps increase our skills. So there's obviously information there about design. I'm not going to go too much into that. We have a paid design service. We have a free design service. If you need to know more, talk to one of the team. Backflow prevention. So I've got here a commercial backflow prevention device. This is really, really important from a compliance standpoint, but also from a doing the right thing by the rest of the world standpoint. Backflow prevention devices are designed to stop the water that you are working with from getting potentially contaminated and going back into the drinking water supply of the rest of the world. So there's different levels of hazard. We've got low hazard, medium hazard, and high hazard. The higher the hazard, the more expensive and the more intricate the backflow prevention device is. We don't actually have an RPZ sitting here. They're not that commonly used anymore, but back in kind of the 06, 07, 08 period when the drought was kind of coming off, there was a lot of subsurface irrigation being installed in South Australia, and there was a chemical being added to the drip tube called Treflan, which is a root intrusion inhibitor, which, from what I understand, is banned in Europe now. Might be banned in the US. So it's very... Yeah, we can't get it, can we? No, we've got it though if anyone wants some. But yeah, it's not ideal, and you know they're finding micro particles of it in food, and they use it in agriculture for similar purposes. Anyway, when that system was installed, you'd put an RPZ device in to protect the house, and then you'd put another RPZ device to protect the house from contaminating the community. And that was, you were looking at kind of 12, this is back in 06, 07, 08, you're looking at about $1,200 or $1,500 for 2 of them installed. And they had to be tested every year. So that's a testable device, as is this. So once these are installed, they get registered with SA Water, and then they require that they get tested every 2 years, I think. It might be 1, I think it's 2. So a licensed plumber goes out with a testing device and makes sure that they're actually still working, because there's no point putting a backflow prevention device in and it doesn't work. You might as well have not put it in. So be aware of your requirement to put backflow prevention devices in. Obviously, if you're doing commercial systems, I'm seeing logos and kind of going, yep, okay, cool. It's going to be on the plan anyway, so you're probably going to, if you get a supply from an irrigation shop, it's going to come with the backflow prevention device, or your business has organised a licensed plumber to come and do the backflow, and then you're going from the backflow onwards. So the most simplistic backflow prevention device is this one. It goes onto a tap, so you would mount, there's one there. This is our artistic impression of an irrigation system. Most of the things that we're going to talk about today are here. So this would be, if you went down a tap pathway, there is still the requirement and the availability to put a backflow prevention device on a garden tap, and it would probably be one of the things that gets overlooked the most. So the idea is there's a spring-loaded device in here that if there was a pipe got broken in your house, or if a mains pipe got damaged at the road, when that suction from that breakage occurs, it can't draw product back through drip tube or sprinklers back into your drinking system or back into the mains water of the road. So it's important, you think about the amount of chemicals that we're spraying to manage pests in the garden, or obviously, there can be the potential for cross connections between recycled water and mains water, and so that's why those devices will come into play. Again, like everything else I'm talking about, if you're not sure, by all means ask. That you can talk to SA Water's Office of the Technical Regulator about backflow if you need to. They've got a phone number for that, or you can come and talk to our team. All right, flow tests. I talked about design before, and for us to design the best possible system possible, in addition to a scaled plan, which is mentioned further on, and all of the locations of things, so paths, potential hazards, slopes, fences, anything that might impact the system, having an accurate pressure and flow is really important. Now we've got this device here, which is it's something that we make in-house and sell. That's a digital flow meter. That's a pressure gauge. So we would attach this to a tap, have the water flowing through it. You can isolate the water altogether, and then that will give you the pressure of the static, which is when the water's off. And then what we would do is open this ball valve until we get a certain flow flowing through here. Until we get a certain pressure here. So we would be looking for 2 or 3 data points for a commercial system, or even a residential system that's going to help. And we might get one at 300 kPa, one at 400 kPa, and one at 500 kPa, and we'll measure the flow that's moving through at those pressures, and then you bring that information to us. And that gives our team the ability to get an understanding of the water, and then make sure that your system is the most efficient system possible. The idea there is that if we design a system and have to make assumptions around flow, we're going to be conservative so that we don't get stuck. And in doing so, we're going to have a lot of solenoid valves. So you might go out and quote this irrigation system that you've come to us and said, I'm not sure. And you've got a 6-valve system, which is going to cost the client more money when it could have been a 4-valve system or a 3-valve system. And in addition to that, you might lose the job because you're quoting against someone that actually did a flow test.
The importance of that as well is each suburb's different. So what you think is enough pressure, like there's heaps of pressure. It's actually really important. Like
even street to street as much as suburb to suburb.
Yeah, Hove might have 20 litres a minute coming out of their tap, which is really low. But the pressure, you can only get you can't get 5 sprinklers on it. You wouldn't push them up because the pressure was so low. So you had to split it into 3 stations for 10 sprinklers, right? So sometimes you can catch you out, and like you don't want to have to go back to jobs that you've already completed because you're not getting paid for that time. If that makes sense. So getting it right at the beginning is design.
The other advantage of doing all of this work before you start, one, you might not even start the job because you've identified that it's just not going to be possible to pop sprinklers up, so you might have to do a drip system because there's not enough pressure for sprinklers because drip tube requires less pressure. But also, if something changes after you finish the job, say they build a house next door and pull it from the same meter, or they install additional hardware between where you were getting the water from and where you were, most times you're going to get a phone call saying your system doesn't work anymore, or your system doesn't work, you've stuffed up. Now, it was working for 6 months, why is it not working now? You can go back and do another pressure versus flow test and go, well, here's the video of the one we did 12 months ago when we quoted the job. Something's changed. So it's not us, that you've had a situation change. And that also gives your client something that's evidentiary to be able to take to SA Water and go, what's happened to or United Water or whoever's in charge of the mains. Because as those pipeworks age, that network's getting more and more fragile. And if you think about it, if you're responsible for the maintenance of an aging water network and you get paid the same regardless of how many repairs you do, you're going to make decisions that reduce the amount of breakages, right? Now, that's just a conspiracy theory. But if you can reduce the pressure and the pressure on those systems and save breakages, then you're not going to be doing repairs, and then obviously residents are going to have lower pressure versus flow. The other thing is a lot of the devices that we're installing in our houses now have maximum pressures. So all new houses are getting a fixed pressure reducer installed at the front of the house, which is like this, which is a 500 kPa fixed pressure reducer. It's designed to protect the water filter, the water into the fridge, the water into the washing machine, that kind of thing. 500 kPa is kind of a shitty line for pressure for us. Like, if it would be really nice if you came to us and said, I've got 600 or 700 or 800 kPa coming into the house. It's a lot more usable. 500, once you start moving through devices, drops to 400 pretty quickly. Sprinklers are, looking for 350. If you have too much friction loss through the parts or the infrastructure that we put in place to either protect the water from backflowing or the solenoid valves, eventually, if it goes low enough, the sprinkler won't. It might pop up and just do a really bad job, or it won't pop up, and that's a problem. So, getting us that data is quite important.
Can they be adjusted, those pressure things?
Some can, some can't.
That one you showed can.
Yeah, so you'll probably find.
Like 1,300. So I had one put on my house because it was just lying.
Yeah.
Shit, too much pressure.
Yeah. They do make an adjustable one, but again, if a non-adjustable one's $40, an adjustable one's $80. And if you're a builder, what one are you putting on?
Yeah.
So if you had it fitted, you might be in a situation where you're fine, and it's a.
Depends on the plumber.
Yeah, it's all economics, right? Like, so if you do choose to adjust it, there's a screw on the top. It actually says on the factory set 500 kPa. Where is it? And it can run from 150 to 600, so it doesn't help much. The other option is just to rip it out, but obviously you'd be a licensed plumber if you were doing that. You can pressure reduce individual areas. So if you were building, I have done this. We don't have a pressure reducer on my house because I want my skin to come off when I have a shower. Like, I don't want any, slow flow. I don't want to fill up a bucket and have to go have a nap between the start and the finish. So we've ripped everything out. And if it wasn't strong enough, I put a pump system in, and I've obviously got access to a lot of stuff. But if I did have a pressure reducer on my house and I was worried about being able to irrigate well, I'd probably run a separate main line in front of that and tap it at my water meter and send that back around to the back of the house, and then have a 32, we've got 32 mil blue line running from the front to the back, and then you can run more stuff. And the cost, especially if you've got a big block, the cost of that infrastructure might outweigh, it might be a saving compared to having to put in more solenoid valves or to reduce your watering window, which may matter if you're...
Provided you can put another line in from.
That's right. Yeah, and it's just going to come down to your situation. If you're not cutting up concrete exposed ag pathways to try and put in, so you don't have 4 valves. That it's all But the beautiful thing about the available data that we have as an irrigation shop is that you don't have to cut concrete and work it out later. You can come in, talk to us about the flow that you've got in the front yard, the flow you've got in the backyard, the design that you've got in mind, what sprinklers you're thinking of using, and we can do the numbers at the counter, and then you can go, okay, cool, that makes sense. Like, it's $200 difference. I'm not cutting my concrete. Or I can't even pop sprinklers up. I'm going to put a 5,000 litre rainwater tank in my backyard and have it fill up slowly for a period and then pump water through the system, and then it drains down, and then we have a break and then it fills back up. So there's a lot of different options that we can do to help meet the requirements of people's irrigation. You can borrow it or buy it. Yep. So we have that as a, part of our offering. If you were just needing to use it once, just come say, look, can I borrow it? I think they charge a $40 deposit or a carton. I don't know what it is. 40. Do you know? I don't know.
What's it worth?
180, I think, including. I think it's around 180. Or you could buy the parts that make this up, probably for less, and build it yourself. So
it's a really good tool, and a lot of people use it just for this saving time. Just plop that on there.
You'll pay off the cost of the tool in infrastructure costs, time costs, but
So it depends how much you use it, I guess. You use it once a week.
well, if it saves you $180 a year,
You could take that to every
but I try not to push it too much because I don't want, I worry about these training sessions becoming like a go to the back of the room and sign up and we'll close your night. It's not about selling stuff, but yeah, look, that's why we not rent them, we hire them. Luke, do you know, Justin, if railways have one down there that you lend to people? Yeah, so you've got one at Ranella, one at Kent Town, and one at Dry Creek. It's not often that they're not there. If people are using them regularly enough, we try to encourage them to buy one, or if they buy a big enough job, we'll push one into a deal. Same with electrofusion welders. We'd have welders out on hire for commercial landscapers, and they'd have it for a month. And you're like, next time you win a job for 50 grand, I'll give you a welder. And they're like, oh, okay. It helps us. Yeah. Yeah. Yeah.
Compression change.
Yes. Yep. So that's the impact of the infrastructure that's outside of the house. So they can turn it down. So to stop pipes breaking. The only way to probably get it to go up, I think if you've got really low flow, there's a number that SA Water would consider not humanly acceptable, which might be below 12 litres a minute. I don't know the number, but if you think about if you can't shower effectively, there's a human health concern, then they might come and do something about it. And that might be, I think they shape pipes. I don't know if you said there was a plumber. There's one plumber here. Sometimes if there's not enough flow, the SA Water will come and shake the pipes, and it's to get everything out of it, which might increase it. But I haven't ever had to have that done. One other thing that I was thinking of when you were talking about the client, sometimes large blocks of land owned by thrifty, wealthy people can have an unrealistic expectation around how much water costs to look after a 3,000 square metre block with amazing lawns and gardens. And you can actually use the data from our irrigation designs to reverse engineer the approximate cost of water for the year based on going, well, this is the rainfall we're expecting. We're probably going to irrigate for this much in this month, this much in this month, this much in this month. And if you times that by the cost of water at the moment, this is what it is. So the next thing on the sheet there is about precipitation. Mudge thinks I love precipitation, but I'm not going to talk about it too much. There's a couple of definitions there, and there's some information from Hunter Industries around precipitation. I think the main thing to think about from a precipitation standpoint is that when we're irrigating, we're simulating rainfall, and there is, as I've said 100 times so far, data around what we're doing, and so we can work out how much precipitation can be applied per period of time, and then we can set up a system to suit that. So you'll have kind of data points for turf and gardens and trees and plants around how much water is recommended to keep it in a certain level. So there's an IPOS standard at council level where they'll say to keep this area of turf at a grade where A grade AFL can be played, or cricket, or it's safe enough for children to be there, or whatever it is. I can't explain it fully, but there might be 4 levels. They'll say we need to deliver 10 or 15 or 20 mil of equivalent rainfall per week. Now we can do that. We know that an MP rotator delivers 11 mil an hour. A Rainbird R-Van's 14 or 15 or 16. You might design a PGP, like a Hunter PGP system at 40, and then we can reverse engineer the system to suit. There's a bit of information on that. What is it, page 8, around drip and spray, and then the differences with precipitation. I guess when one thing goes one way, the other thing goes the other way. So high precipitation requires high flow. That's just common sense, right? If you're going to put out a lot of water in a short amount of time, you're going to need a lot of water. And this is when you run into those situations where you might only be able to run 1 or 2 or 3 sprinklers at a time, but the sprinkler's putting out so much water that you're actually only needing to water for 6 minutes, and you've done the equivalent of what, say, an MP rotator might do in an hour. So these are all the things that we take into consideration when we're designing an irrigation system. And prior to MP rotators and R-Vans being, you know, the go-to sprinklers in the market, it was a bit more complicated because we were using vans, and every, you know, a 10A or like a 12A and a 15A and a 17A had different precipitation. So you either had to put different sprinklers on different lines and adjust the times, or you'd have to just go, well, it's close enough, it's a rental property, and just turn it off once the path starts flooding. And it's not ideal. When we're designing ovals, we'll have all the 360 sprinklers on the same line, or we'll put the 180 sprinklers with a different nozzle, so they put half as much water out per minute because they're doing their pass twice as often. So this is all the things that we're taking into consideration. You shouldn't have to think about it, right? You should be able to come to an irrigation shop. It doesn't have to be us. There's plenty of shops that do this, and get a scale diagram, tell them what you need, and they'll be able to give you the information that is required to install the system. And then you might get a valve table. So commercially, we'll have a valve table that says the drip tube's putting out 10 mil an hour, the sprinklers are putting out 14 mil an hour, and then at the end of the table, it will say number of mil per hour, or number of minutes to put out 10 mil of equivalent rainfall. And then you can adjust your irrigation programming to suit that. So that's why, you know, if you've got a month where we might have 5 or 6 mil of rainfall in a fortnight, we still need to irrigate because we're not getting the amount of water that we need, but you can adjust your controller to suit. And that's when you start getting into that smart controller place where like a Hunter HydroWise will communicate back with weather data and can adjust the amount of water that it's delivering, because the controller knows what it's delivering. It's going, well, station 1's putting out 10 mil, we had 12 mil yesterday, I'm not going to water. Or station 1's going to put out 10 mil, we had 4 mil yesterday, I'm just going to put out 6 mil today, so that we're being efficient with our water. Any questions about anything so far? All good. I feel like I was going to say I'm making good time, but every time I say that,
No, you are.
we collapse.
Up and airy, mate.
All right. Sorry, go.
It sounds like what you're describing are big, serious systems, and I do very little systems.
Okay. It's not, like it is, and it's not. So the theory applies at any size. It's just the size of the product that changes once we start getting crazy. So this system here is meant to resemble an irrigation system that you put in a residential property. So you could put in like if you had a courtyard property with, you know, a lot of the times they'll have a path down the middle and they might have 2 lawns, one on either side of the path that are 3 meters by 3 meters, and then there's a back lawn that might be 4 meters by 8 meters and a garden bed around it. We can still get the precipitation of those lawns to 10 mil. And that lawn doesn't require any different amounts of water because it's in a house compared to a school or a reserve. So the theory kind of stands. It's just that once you get up to the commercial levels and golf, the pipes that are delivering the water and the valves that are like, like the gentleman sitting next to you would be, this solenoid valve wouldn't have any place at that golf course, right? The smallest valves they'd be putting in would be 40 mil, they'd have 50 mil valves, they'd have 80 mil valves. They actuate the same, they run on the same cables, the science behind the controllers are the same. They just go out through bigger pipe. So there'll be a big piece of PVC coming out and then it will go to sprinkler, or actually some of the sprinklers actually have a valve in them. So there's so much water going through that the actual sprinkler is a valve and a sprinkler all in one, and one pops up. So, or they can individually control them. So does that answer your question?
I'm like below kindergarten level. I understand.
That's all right, I was too.
How this all works.
Yep. Hopefully
Just don't get it.
in another hour, you'll be a lot closer. So I'll start talking about, I'll explain a little bit about how the water gets delivered, and that might help you understand the precipitation. So with like this, where do we got? Lawn and garden. So when we have a lawn, we might have, I'm going to do a square because it's easier for me. So if they were 4 meters by 4 meters, and then you might have a lawn, a garden that's a similar size. We want to ensure that we're delivering water correctly, right? So we do head-to-head for our sprinklers. So we'd put, if we were doing MP rotators, we'd have a sprinkler in each corner, and that would be the maroon one, which every single one of you in here has probably touched at some point. It's a 4.1 meter radius. That sprinkler there waters out to that one and goes to that one. That sprinkler goes from that one to that one. That sprinkler goes from that one to that one, and then that one goes from that one to that one. So they're all hitting each other. If you put a cup anywhere on that lawn, the theory would be that in a windless environment, every single one of those cups would have the same amount of water go in it. And that number in mil, you can't just measure the mils, you have to have the right system. But it would equate to, if you go into these MP rotator books, you've got data, so I'm talking about the sprinkler that's at the top there. At 280 kPa, you've got 4.1, so if you actually follow along, you've got the arc and the pressure, so we've got these 90-degree arcs. Then we've got 4.1 meter radius, so in a square configuration, you'll see there's the number 11 there. That's the amount of millimeters of equivalent rainfall. So 1 square meter of area with 1 millimeter of rainfall is 1 litre of water. So if that was 100 square metres and you had 10 mil, you've had 1,000 litres fall on it in that period. Does that make sense? Once this clicks, like you'll have a moment where you're like, yeah, that makes sense. It's so easy. So what we're trying to do is we're simulating rain falling evenly, and to be honest, irrigation is going to deliver water more efficiently than the rain will, because it's not moving, it's generally not going to be windy if you're watering at the right time. So by doing this, we've got one like head to head. We've got matched precipitation. That's what the MP and MP rotator stands for, matched precipitation. So anywhere on that lawn is getting exactly the same amount of water. If you remove these two sprinklers, it's no longer matched, and you're getting gaps. So the water's going to be there and there, but this whole area is not being watered. And that's why when people come in here and go, oh, can't we just put it on one side and just like flood it and just hope for the best? It's not how this was designed to be done. And with a Kikuyu lawn in most situations, you can flood it and it's probably going to be fine, but it really depends what you're trying to achieve. Now, with drip tube, it's no different. You can match precipitation drip tube. The difference will be the delivery method. So we would usually have a header pipe and a collection pipe, which is exactly this here. You can connect to them using elbows. You can use punch, like takeoff adapters, which we can have a play with if you want to. You can use tees, you can clip them with plastic clips, you can clip them with metal clips, however you want. The precipitation will vary depending on the spacing of the drip tube, the spacing of the dripper, and the flow of water coming out of the dripper. So all of this here is drip tube. We've got 0.4, 1.6, we've probably got 0.3 over there somewhere. Rainbird make it 2.4 or 2.5 litres per minute, and they make it 3.5. So what that litrage refers to is the amount of water that would come out of each individual dripper every hour if the system's running at the right pressure. So based on that, we can start to work out how much water is going to fall here. To get to 10 mil, and this is what we try to design to from a soil capability standpoint. To get to 10 mil, we would have a 0.4, 0.4, 1.6. So every dripper, so there'd be a drip tube there, and there'd be a dripper on it every 400, and there'd be another row next to it, and there'd be a dripper on it every 400. And if we do that with a 1.6 litre an hour drip tube, we get 10 mil an hour of equivalent rainfall, which is almost the same as this.
Is it actually a drip tube on the ground pipe or is it small?
It's a dripper. Yep. So it can sit on the surface, or it can be subsurface, or it can be on the surface under mulch. So what would happen in a perfect world is the soil. No, that's a garden. Yep. But you can water lawn like this. So the same system. If that had a green edge, you put lawn on top of it, and you just use a drip tube that's suitable for use under lawn, and then you take your chances with root intrusion based on the fact that we're. Yeah. So any of the developments that we're designing at the moment, it's all spec like that. So Playford Council right now, if you do a commercial system, it's 0.4, 0.4, 1.6. Because then they know that no matter where they plant a plant in there, it's going to get water. That's the litres per minute from the dripper. So what they then do is you work out, so if this was 100 square metres, you can work out how many drippers there are. So there's formulas for this, and you could probably just Google precipitation formula, it would work it out. But what it is effectively how many drippers there are inside that 100 square metres, how many litres of water they're putting out per hour. You times them together and you get the total number of litres to the area, divide it by 100, then you've got how many litres per square metre you put out, and that's your precipitation rate. So if you start getting a bit crazy and going like 0.3, 0.3, 2.4, I think 0.3, 0.3, 2.4 was like 17 mil an hour. Now, when we get really high with precip, especially the harder soils that we've got out here, the soil can't take it. And so you've got water sitting on top of the soil or it's starting to run off, and that's when you'll get to those sites where there's a sloped embankment and there's all this soil coming across the path because they've put out too much water. It can still happen with sprinklers. So the idea might be that you just have cycle and soak, so you'll set your controller up to turn on. I do it at home because I've got a slope and I did a really shitty job, but I'll water for 15 minutes and then I'll leave it for an hour and a half, then I'll water for another 15 minutes. So it still gets that half an hour, so it's going to get 5 or 6 mil, but it's not all sitting in the bottom corner of a lawn, which has then got...
Which is called cycle and soak.
Yeah, that's what I said.
It's,
all of that.
Controllers have that built into the controller.
Yeah. So, if you go, that's all right, as long as you're doing social media, that's all that matters. So if you can... The only time you can't really work out your precipitation would be sort of like at a farm where you've got a pot and you just put one bubbler in a pot. You could work out theoretically the precipitation and go with the circumference of that pot's this much. So you know it's like, I don't know, a third of a square metre and you're putting in 20 litres. You might be putting in like, I don't know, 30 or 40 mil of equivalent rainfall. You could work it out if that was of interest to you guys. And you can get stakes that will give you pressure compensated flow. I don't know if that's further in, but I'll talk about it now. So with the 1.6 litre an hour drip tube, everything we stock is pressure compensated. So if it's got the right pressure reducer or the right amount of pressure is coming into the drip tube, it will deliver 1.6 litres an hour per dripper, no matter where it is on the line. And you can, I guess, come unstuck if you use a non-compensating drip tube, where the end of the line might put out less water per minute than it's meant to, or less water per hour, and then you're in a situation where you've kind of got 6 mil down here, and you've got 12 mil up here because the water's being forced out the dripper harder at the point where the water's coming in and less at the bottom. When we do audits for a few councils, and we'll do a distribution uniformity test. This is more advanced stuff. We put those catch cans out, so effectively the cups I was talking about, we put them out. We put out 25 or something, like 5 by 5, and we run the system for 15 minutes. We test the wind, and then we measure how much water's in each of those cups, and then it will tell us, we can actually heat map it to a point where this is struggling, or we've got, so the distribution uniformity, like we'd have a theoretical distribution uniformity when we design a system, and then you've got an actual one when you go put it in, and then you've got an actual one 2 years later after the sprinklers have been overgrown by turf and they've been kicked by football players or damaged by vandals. And then it gives you an opportunity to go, all right, this is what it was meant to be. We can test it once it's installed and see how close it is. So that might be something that you'll start to see in commercial landscaping soon, that the more advanced councils will say, designer X has designed the system, the distribution uniformity or the theoretical distribution or the theoretical amount of water that should be falling is 86%. They'll come and do an audit on that, and if you don't hit 86 or higher, they'll make you rectify the installation because they can if you sign the contract, obviously. And it might be because that sprinkler has the wrong nozzle in it, or it's leaning back a bit, or the pressure reducer is not right, or there's a number of different things. So it can get that detailed, and that obviously sounds very extreme commercially, but at the residential level, all of the theory stays the same. It's just smaller. So when you get a garden and the person goes, well, I don't know how to do this, and like then there's just a tree there and a tree there, you're not getting even watering. It might be fine. And if you've got an arid garden that's kind of sparsely planted, it might be ideal. But that's not how we would design stuff traditionally. And what we would do in most cases is design the best possible system available. And then if you say it's too expensive or the client doesn't want to pay for it, then we start shaving stuff to a point. But we don't want to be shaving stuff like this. And we don't want to be shaving pressure reducers if we can avoid it. You know, we might do less pegs, or you might choose to remove air release valves or flushing valves. But obviously the more you take off, the higher risk you've got of something going wrong. Any questions around that? Cool. Valves. So I want to spend some time talking about solenoid valves because I think solenoid valves are one of the things that catch people out the most. And the reality is, given enough time and not much time, most of you would be able to put in the skeleton of an irrigation system. It's the brains and I guess the controller and the valve that becomes quite complicated because it's something that's foreign to people. The crazy thing is it's not that hard. And once you've done it once or twice, like anything, you'll get confident with it and you start to understand it. Like if we can soon, we'll go out and we'll build this equivalent out there and like put some fittings together and you can test out. Like, and look, everyone here is going to have a different skill level. So if you've done all this before, you might just want to stand back and let other people do it. But it's hard, like I said at the start, it's hard to know what, you know, I'm short of doing one-on-one training, there's going to be stuff that we're going to talk about that you already know, and there's probably going to be stuff that you don't. So with solenoid valves, there are two different ways of them, or there's two different electronic ways of them actuating, and then there's a manual way. So what we've got here is a Hunter and a Rainbird solenoid valve. There's lots of different brands, and you can buy solenoid valves at hardware shops, and you can probably buy them on Alibaba and get some random stuff brought in, or you can buy from an irrigation shop where you're going to get Rainbird, Hunter, Rickdell, professional brands that are backed by shops. The reality is all of them work the same, barring a few minor changes. Some of them are reverse flow, so the Rainbird ones are reverse flow, so it opens slightly differently, but the theory on how they open is all the same. I would encourage you to try and stick with recognizable brands if you plan to operate in the industry for more than 5 years. There's been plenty of times where a manufacturer who does really well making blue line fittings decides they're going to make a move into solenoid valves and grab some valve from some factory in Italy and brings in 1 million of them, and then that doesn't work and they don't sell them again, and then you're stuck. Solenoid valves are really, really easy to maintain if you've got the same parts to replace the parts that are in the ground. If you can't get matching parts, you're ripping the whole valve out, and most of the time they're in a hard situation where they're threaded. You know, these are a manifold that you can get them out quite easily, but if you can't get the base out, to be able to replace the top and the diaphragm is quite easy. So, solenoid valves can be turned on using a traditional controller, which is this one here. It's wired to mains, and that controller has a transformer in it that reduces the electrical current from 240 volts to 24 volts alternating current using a transformer, which is there. And then we join the cables to the valve, right? So that's consistently getting power from the mains, and then the clock tells it to give some power to the valve. It sends power out through the common and the valve number. So I'm going to draw that up. I'm going to jump back to controllers and I'll jump forward to valves. This is like the first time I jumped around. Going well.
It's been a while.
I didn't have alcohol yesterday, so I feel pretty fresh. So, when you've got an irrigation controller, It's got ports on it, so it's got the common 1, 2, 3, and 4. So you might have 4 solenoid valves here, and they've got a coil on top of them with wires coming out of it. This bit here is called the coil. It's an electromagnet that lifts a pin that opens a solenoid valve. The ones that have the same coloured cables are an alternating current valve. It doesn't matter which way you wire these up. That can go to the common, that can go to the 1. So what we're going to be doing is we'd be wiring 1 into the C and 1 into the 1, and then valve 2 would be wired into the 2, and valve 3 would be wired into the 3, and valve 4 would be wired into the 4. When that controller tells the solenoid valve to turn on, it sends an electrical current through the C, and then whatever valve it's trying to turn on, it creates an electrical circuit. It's alternating current, so there's electricity moving back and forth through these wires. It's using an electromagnetic force to lift a pin in here. That pin lifts up, changes the pressure in the valve, water pushes through it. If that pin drops, the pressure changes back, closes, water flow, pressure rises, and it closes the valve. You can simulate that process by turning it like that. So when you turn a coil a quarter turn, you've lifted the pin enough that you're replicating the electrical version of what I've just described. Now, I used to install irrigation a long, long time ago, and I had a little bit of a system that worked for me, and you guys can do whatever you want, and this is kind of a bit of an Australian system, but the common was always black, and we'd wire, so you're wiring the cable to one of each of the cables coming off the solenoid valves. If any of you are uncomfortable being famous on social media, let me know as well, and we'll get you blocked out. We're yet to have any kind of parolees or people on the run, but you never know. Then I would, in alphabetical order, I'd do each of the rest of the cables. So you'll usually have like brown, blue, white. So you might do brown, whatever the colours are that are in alphabetical. So then I'd know when I was going back to a job that there was a system. There is no standard system, but so number 1, you might wire to that one, and then number 2, you wire to that one, and then number 3, you'd wire to that one, and then so on. So then what will happen is the controller will turn on it'll send an electrical current through the C, which is the common, and valve 1, 2, 3, or 4. If you have more than one valve turning on at once, there's a likelihood that you've crossed some cables over. So if you turn on valve number 1 electronically, but 1 and 2 both come on at the same time, and then you turn it off, and they both turn off, somehow you've got the common, no worries, but then you've got that green wire is also joined to the number 2 valve, and they're both turning on at the same time. Electronically, they can only turn on when there's a complete circuit. Manually, if you turn it and forget about it, it's staying on forever. So be careful with that one. Now, so that's wiring up those. That's a traditional 24 volt AC solenoid valve system. There are also Hunter nodes, which I would be very surprised if any of you are not aware what that is. Do we have one out here, Mudge?
I reckon there was one in one.
There we go. So that's a Hunter node. So a Hunter node is like the Esky of battery operated solenoid valve controllers. As in, it's the market name, but it's its own product, right? So there's plenty of other people that make battery operated controllers for solenoid valves, but people just call it a node because that's the industry leader.
You like collaborate.
Yeah, and Esky, let's keep going. Now, the sort of gurney, you got anyone else? It's good. We need prizes for these, Mudge. So, I'm looking for a solenoid valve with 2 different coloured cables.
Which is like DC coil?
Yeah, that's what I'm looking for.
None of those.
No. So a DC coil, the polarity matters. So what I just talked about there, it didn't matter what, like the 2 red wires, doesn't matter. When you're wiring up a Hunter node, or the equivalent, there's no equivalent, or the attempted equivalent, they're going to love that one at Rainbow, of this, the black must go to the black and the red must go to the red. If it doesn't do that, it will not work. So That's alternating current, this is direct current. So that's how that works. The turning of the coil to open up a solenoid valve with this still works. You can also open up a DC coil with a 9 volt battery and just tap both wires on the battery. What it does is it sends a 9 volt pulse through to the coil. It's called a latching coil, so it latches the pin in here up, and then it won't drop that pin and it gets sent back another signal to unlatch. Disadvantage of this, if it went flat while it was on, it won't turn off. Very unlikely. If that cable gets cut or the power to that goes out while these are on, they all turn off. So if you had a power outage to that controller for a long period of time, you're not watering that. You won't know until you get, dead stuff. These will obviously need to have their batteries replaced every 2 years, but it's also very dependent on the frequency. They hold 2 9 volt batteries. They will operate with one. Obviously 2 just means you're not replacing them as regular. One of their new versions is the Bluetooth. You can actually go past with a mobile phone and check the battery life without lifting a valve box lid. So obviously Bluetooth, you have to be within, 15 meters, or not even now, about 10 maybe. Depends on what version of Bluetooth they've used. Questions?
Obviously, alternating one with Dira, is that?
As in that's Dira.
Is that cheaper than
The coils are Dira, so the valves are Dira. It depends on what data you put into your costing. So if you include having to get cable from a controller to the valves, or adding a power point somewhere that doesn't exist, if it's a roundabout, it's not even a question. There's no power on a roundabout, but there's water there, so they'll use these. So I've referred to Playford before, and I do that a lot because we're close and we do so much work with them. They've got hundreds of nodes, and there was a period where they'd have to go and change all the batteries or check the batteries by opening the box, pulling the lid off and checking it. Now they've obviously got the advantage of using the Bluetooth on their phones, but I think for a couple of valves, it's probably not too much different. What's a node? 135 train? I shouldn't say that, this will go on YouTube.
The other thing is you're buying an AC, you're buying a valve with an AC coil attached, right? Then you're buying the DC latching coil separate.
If you buy multiples.
If you buy multiples, correct.
Yeah.
So
If you buy a single station node, it will come all complete.
essentially, if you're putting a lot of these in, you're going to have a lot of AC coils left over.
Which you can give to us and we'll sell them.
Which we would sell a lot of because I can't remember whether it's cheaper or if it's just a similar price.
It changes from year to year. So it depends on who's importing. So sometimes they'll have it that it's you just buy the DC, it'll be a code with a coil, so you'll get it complete. And then other years you've got to buy, it's cheaper to buy a PGV and a coil separately, and then you're dumping all these coils, which is kind of silly, but it's supply and demand. It's like 75 mil stormwater. It's smaller, but it's so much more expensive, and it's just because it's not used very often. So the theory still stands, 1-to-1 kind of thing. You still get all the blacks will go to the commons, but then all the reds will go 1, 2, 3, and 4. So you can get multiple station versions of these. Some of them do 8 or 12 now. What's the?
8.
Yeah.
But only up to Bluetooth. I think it's only up.
Yeah. If you're doing that many, it's getting a bit out of control. It might be worth looking at a proper system. So what it does, sends electricity through to the solenoid valve, lifts it up, pops it open, water goes through, no problems. I'll talk about troubleshooting solenoid valves. I just want to explain. So they're obviously on a manifold there. These are a swivel manifold, so you can undo them and take them apart really easily from underground. You can make manifolds out of PVC. I think we've got that written, in there. I'm not going to go into that. We can show you them at some point. Controllers, they do indoor and outdoor. Generally, shops won't hold indoor controllers anymore. You might get them at hardware shops because the $10 difference matters, but when you're buying a professional controller, we sometimes choose to derange things because the gap's not worth it, or when you buy an indoor controller, the transformer's external, so you've got this big plug pack that you've got to try and find somewhere to put. It's all inclusive, so it just plugs in, and the cost got closer. It was the same when we moved from non-pressure compensating drip tube to pressure compensating drip tube. There was a period where the gap was quite large, and when it got within 10%, there was no point stocking an alpha and a beta. You just had too many codes. You're better off just stocking one and trying to be competitive on it. So There is a bit of information in there about tap timers. Again, I'm happy to talk about them. I'd recommend you don't use them if you can avoid it. They're getting better. Just be careful if you're buying tap timers that you check the pressure rating on the timer. A lot of them aren't mains pressure rated, so you're finding that you're putting them at a holiday house or you're putting them at your house while you go on holidays, and you're getting home and the internals have blown and you've flooded things because you've chosen to buy a product that was never going to work. Hunter make mains pressure ones.
They up to
They're pretty high.
600.
Yeah.
I think.
No, it's higher than that, I reckon.
Yeah, I think I checked one the other day on the packet. It wasn't that high, but
Sorry, we'll put money on it.
yeah, well, I'll go grab one.
No,
But
how much?
if your customer's adamant that they want a tap timer,
I reckon it's like 827.
you can put pressure reducers that will hold pressure. So there's, you've got this one here, which is good only when pressure's running through it.
Yeah, it can't hold static pressure.
Can't hold
Just
static
like-
pressure. So then you can have one above the tap timer that will
Static.
not destroy.
It won't blow up, yeah.
I'll go find this and improve it.
I reckon it's in the 800s. Anyway, I'm sure Matt Mudge is right. You were right yesterday when you said about the lighting training. Oh, we're not talking about that, are we? All right. There's a few notes in there about ball valves and manifolds, valve boxes. But I want to go into troubleshooting of solenoid valves before we can kind of start clicking stuff together. We do have a decent amount of time left, so it'll give us an opportunity to put, for everyone to kind of have a shot, but also, obviously, we see it all the time. Once everyone kind of spreads out, everyone's got a question. So if there are things that are on your mind and you want to have a shot at doing something that you haven't had access to in the business that you work for, you want to, wire up a solenoid valve, you want to program a controller, I probably can be here till about 5:10, and then so we can do whatever. But there's also pizza. So with the solenoid valve, I want to talk about troubleshooting them because it's one of the main things we get phone calls about, and I think that talking about it for 5 or 10 minutes will probably save you a lot of time. So I haven't done this for a while. So really, you're generally going to have two issues. Your solenoid valve won't open or it won't close. There's going to be other times where it's half closed and it's drizzling water out, but the reality is most of the time it's going to be won't open or won't close. And your main issues, I haven't done this before, but I think this might work, are power and water. So the only two things that a solenoid valve requires to operate is power and water. So if it won't open, it's because one of the reasons could be that it's not getting power. So I drew that before. You might find that the controller's been told not to turn on. So when you go out to a job and the client's like, solenoid valve will not open, do every possible troubleshooting thing you can do without taking tools out of your van first, right? So you want to start thinking about checking that things are on, making sure water's on, making sure things have been installed the right way. You don't want to go grabbing a drill and opening up the solenoid valve and ripping the diaphragm out first, because then you've started to do something. And I was talking to someone before that said they took one apart, put it back together, and it still didn't fix it. So most of the time, your clients, not most of the time, sometimes your clients will tell you that they haven't touched it, and they have. And so they've got an app on their phone that runs a Wi-Fi enabled controller, and they've gone in and turned on a rain delay for 14 days or whatever, and they're ringing you saying it won't open. Sometimes, if you've got parental access to their controller, you can troubleshoot that before you have to go to their house. And that, if I was installing, I would be ensuring that I had parental access to all of my systems and that I had a service available to those clients that we will take care of it. If there's an issue, we'll fix it and we'll send you a bill. And then you can get reports on how much water is being used and if it's turning on, and if they've touched it, you can put passwords on it, you can tell if they've made changes to it, all that kind of thing. If the controller is on and it is working correctly, the next thing to look at is cable. So between the controller, you're going to start chasing down the cables and making sure that the cables haven't been damaged. So sometimes what I might have done is you've checked that it's all working, and I'd take a professional would use a multimeter. I generally didn't have one, so I'd just grab a solenoid valve from the van and go back up to the common and the one, and I'd just put the pieces onto the metals, and I'd tell the controller to turn on, and then this would start vibrating. And I'd go, all right, so the controller works, what's next? And then I'd start chasing down the cable and going, the hard part is between the controller and the valves, you can't see that cable. And sometimes it's going to be a case that that cable's been damaged in the ground by the clients hitting it with a shovel, or even other trades. If you're working on commercial sites, like landscapers pretty much have other trades are shitting on them for the whole job, and then they clean up all the mess, and then they don't get paid. But if you can't check that cable, you can go down and probably do electronic checks on the cable at the other end, but they're wired to the valve, so that makes it quite hard. The next thing you can do is take coils out from one valve to the other. So you might find that valve number 1's not turning on, but valve number 2 is. You can check, like, switch the coils around and see if they work, and then finally you can cut those cables off and wire it to another one, or put a new solenoid valve in, so a new solenoid coil in properly. To identify that the valve's still working in a situation where you're worried about the power, you can check that it works manually first. If you turn that coil a quarter turn and the valve opens, and you turn it a quarter turn and it closes, you've definitely identified that there's an issue with the power of the coil. So it's kind of working through that process. That's if it won't open. From a water standpoint, if it won't open, solenoid valves need a certain amount of pressure to open. They also need to be facing the right way. So, and they also need to have backflows in front of them facing the right way, and they also have to have ball valves turned on. So if that was off, there's no water coming to these valves. It doesn't matter whatever else you do, they're never going to turn on. If that backflow was in backwards, you're not going to get water through at all. So there's no water. So you could turn the bleed screw and you'll let water out, or you could turn the coil and you'll let water out. If no water comes out, that's when I'd start looking at if you can find a valve and seeing that it's on, like making sure that it's on. If you can see the dual check, they've got a direction of flow, check that. I would also be checking that the solenoid valves have been installed the right way around. That happens occasionally. So that's if it won't open. You think of anything else?
No, that's pretty much covered that.
Won't close, same deal. From a power standpoint, the main likelihood of a solenoid valve not closing because of power is because the controller is telling it not to close. Like a lot of times your client will have touched the controller and given it 15 start times that go for 15 hours each, and it's just on all the time. And so they'll ring you saying it's leaking, and it's not actually leaking. It's the fact that the controller's been changed to tell it to water, and it's doing exactly what it was meant to do. It happens most regularly with 4-station controllers that have 4 start times and 4 programs. The 4s just confuse everyone, and they just go and put a start time in every program for every start time in every program for every station, and all of a sudden you've got 16 watering events or more.
I've been a victim of that.
So to avoid that, the most visually simple way of doing it is to have a Wi-Fi enabled controller and to have it controlled via an app. You can open up, like I've got the Rainbird ESPME at my house. I've got an app, it's all on one screen. I can see all my start times. You can't see it inside these controllers. The screens are tiny, and you kind of have to remember what you did on program A, program B, and program C. Plus, you don't know what your clients have done since you left. So it's unlikely that there's going to be a power issue for it not to close. It's very likely it's going to be a water issue. And when I say it's a water issue, there's either not enough water pressure for it to close, which can happen, and then it's generally just drizzling, or there's a blockage in place. So what will happen is the electrical current to that cable through the cables will stop, and the pin will drop, and the electrical side of it said, yep, I've done what I need to do. And then what's meant to happen is there's meant to be enough pressure flowing through that valve to push the diaphragm back down, which we'll open up and have a look at, and it's done. Now, if there's a rock inside the diaphragm, or there's a split in the diaphragm that's caused the diaphragm to not operate how it's meant to, that's pretty much probably one of the earliest situations where you're going to have to get the tools out and actually open up the solenoid valve and start looking around. Reasons that might have happened, we talked about pipe breakages in main lines before. If a mains pipe breaks and they fix it, sometimes you'll get rubble or sand back into your residential system. So if you can, it's nice to try and flush through a tap or something and get any of that out there rather than letting it go to your solenoid valves. If it gets down to your valve, it'll generally be the last one because it kind of gets into the back of there. You can either inspect that by opening the top of the bonnet or by taking the back nut of that manifold off and taking it out. If you're going to start working on those valves, turn that off first. Once you've turned that ball valve off, everything's isolated and you can work on there freely. Also be aware that this is all 24 volt AC and you're not going to kill yourself, so don't start sticking stuff in there or there. Once you've turned that off, you can open your solenoid valves and then you can lightly open it and flush water back through, and you might find that it brings through sand or debris. Then you can inspect the diaphragm and you'll find whether or not it's torn or it might have a calcium build-up depending on where the water's coming from. So that's most of it. You won't always remember that, and we can probably clip this section on its own and make it into a video or put it on YouTube, but YouTube is going to be, and it probably is for a lot of other stuff in your life, your biggest friend. So if you're struggling with anything and you can't get through to us because it's late at night or you're on a weekend, everything that you're ever going to need to know about resetting a controller or programming a node or adjusting an RVN or an MP rotator or wiring up solenoid valves is all there. And some of it's on our channel and some of it's on other channels. Some of it is aggressively salesy and it goes for too long, and some of it's nice and concise, but you'll find what works there, and work through those non-labor intensive parts first. And I don't know if we can make a checklist out of this. I feel like we do.
Yeah, we probably should make a checklist to make it a quick thing, but again, like Clint said, contact your supplier. They should always be willing to help. There is a process of elimination.
There's suppliers out there that won't.
There's probably suppliers that won't, but there is quick ways to narrow it down quickly. Because time is precious these days. We've usually got a long list of jobs to get hold of. Going back to jobs is probably detrimental to most businesses. And to be able to eliminate that problem quickly and narrow it down and be able to fix it will make.
Well, a lot of that troubleshooting can probably be done now. Like when you're not there, you can FaceTime your client and they can show you in the solenoid valve box, and you can start going, all right, what's going on, where and why. And worst case, if it's not really hot, just say, look, just turn that off and we'll be out there on Monday or Tuesday or whenever you want. Like, it's the issues.
Our advanced courses will delve into this a lot deeper.
Yeah, only because the guy that hosted is smart.
We'll bring out the big guns, Matthew Irving, known from such episodes as
Ask Irving, he's the one.
He will go into depth with controllers, go into depth with solenoid valves, and really focus on those shortcuts.
Distribution uniformity, like that kind of stuff. So I think what we might do now is, has anyone got any questions about any of that? Have I missed anything? I always do.
Well, probably if you're going over like actual sprinklers, like when you've got a system and it might be a customer's rung you up and gone, my nozzles are just misty. It's just mist coming out. That could be, you got too much pressure. Instead of like pulling the system apart, you could, and I think Clint's got up there a AccuSync for a Hunter valve. Yep. So there's between the coil and the valve itself is an AccuSync. Now that's a quick, easy way of getting your client out of the ship. Is putting that on, adjusting it, and that will reduce the pressure at the valve, and then the sprinkler can run as it should, right? Something might have changed, council's turned up pressure, who knows what the case is. But yeah, that's, I think they're around $100 though. So, but it'll fix it. You know what I mean? Other than putting a pressure reducer at the beginning of the system, all that sort of stuff.
Well, yeah, like that. It's hard to retrofit that.
Correct.
Whereas this goes there.
I just had what was the other issue? Block sprinklers, right? Flushing your system before you put your nozzles in is going to save you a lot of trouble, right? So the last thing you should put in is your nozzles. Flush that whole system.
They actually have a flushing nozzle on them.
Only on the RVNs?
No, as in the Hunter and the Rainbow bodies have a flushing nozzle. Yeah, that's it.
Yeah, okay. So yeah, that's right. And that's on the sprinkler bodies themselves. So
But we can put that together and we'll build a system out there and flush it. And
that's right. But these are the sort of things that you'll come across.
And putting it into those gunnets.
Yeah, don't ever, and especially on these nozzles, don't rip that off. Just put it in.
yeah, the MP rotators more specifically are super sensitive to dirt, and you can't clean them once they're blocked up. You're buying another
You'll
nozzle.
start hearing
$11.
certain things. You can actually hear the grind because the shit inside it. You can try and clean them, but generally they're done.
I've never seen anyone successfully do it.
So they're very, very good engineered piece of product. Like there's a lot of technology in these.
One thing I didn't talk about is the fittings that we have here and cobra clamps. We're seeing metal clamps introduced into commercial and a lot of residential now. The plastic clips that we stock are Antelco, which are made in St Agnes. They're, the Antelco range is South Australian owned, South Australian made, and we choose to stock that over other brands that are cheaper, and we maintain fair trade pricing by having a lower margin. It's not much difference in cost, but it's enough. You'll find that the plastic clips that the Antelco ones are a lot stronger. So if you've had a bad experience with plastic clamps that you might have bought at a hardware shop, it's probably because they're being made in Vietnam or China, and they're not the same plastic and they're not the same process. These clips here, you can undo them, take them off, bend them, put them back together, and they generally don't break. Yeah, hopefully. So you can stretch them right out. You won't be able to do that with a hardware shop clamp, and so we choose to stock them. But again, Mudge was talking about the amount of time that you don't want to be wasting going back to jobs. If you are concerned about your clips, then going to a cobra, which is a stainless steel clamp, is a great idea. It can give you a point of difference between you and the people that you're competing with. But obviously you want to be communicating that difference in your quotes, otherwise you're going to be $100 more. I mean, I know what these are now, 30 cents versus $1 something, so it adds up when you're putting a lot of clips in. But we'll anyone that wants to, we'll clamp everything up and we'll build a system out there. We'll run some water through the solenoid valves, and then won't even get you to open up a valve, and we'll take a diaphragm out and have a play around with it. But anyone else that's having troubles with their solenoid valves and wants to troubleshoot, we can do that. And like I said, we can do that as much as you want. So if everyone wants to grab a drink if you want one, use the facilities we'll set up outside.